Hi guys, welcome to Tech Geek. So today we are back with the daily Leetcode challenge problem that's convert the sorted array to a binary search tree. So basically that's a quite easy question if you know what a BST is. This is based on the theoretical concept of a BST. That's a Leetcode easy question, Leetcode easy 108. Before beginning, I'd like to request you to please like, share, and subscribe to my channel. And if you have any queries, do let me know through the comment box. Let's see what the question says. The question says you have been given an integer array nums where the elements are sorted in ascending order. So you have a sorted array, right? You have to convert it into height balanced BST. Now, what is a height balanced BST? Height balanced BST is a binary tree in which the depth of two subtrees of every node never differs from 1. Let's say you have a left and right height, so the absolute value of this will be less than or equal to 1, but nothing else. This is kind of a constraint that you have. Okay, and you have to build a tree. So let's you know what is BST. If we talk about a binary search tree, you have a root, the left subtree, the right subtree. You always know the left subtree is less than root, and then we have the right subtree. This is what we need to follow. So this is the constraints that we have, and coming to the fact, we have a sorted array now. So as we know, we need these elements in a sorted manner. So that's what gives us a sorted array will help. Like you have the elements. The only thing you need to figure out is what's going to be the root. Then coming to the left and right. Then again, what's going to be the root for these, and then so on. So that's what you need to figure out. Now let's see. Let's take an example of a binary subtree. Let's say we have this binary tree. Okay, let this be 3. Sorry, uh, 3, 1, and 4. Okay, so this is a BST that you have. I'm taking it in an opposite fashion. Instead of telling you how to build, I'll show you how we can get a sorted array. So that's what makes it quite easy for you. Okay, now see, you have a sorted array. You have to print this elements in a sorted order. You have a BST, you have to print it in a sorted fashion. Like what should be your first point? I guess that's what you could say an in order for this particular tree. How? Let's move from here. Though in order is not like this. We come here, here, and then again. So it's basically the in order part. But let me tell you in this way. We'll begin from the leftmost. 1. This should be the 3. Then 4. If you talk about this subtree, how we began, it went from left, root, right. Okay. Again, when this left part is done, we come to the root. Again, coming to the right one. This right is also like left, right, left, root, and right. So if you can see, this is what we did in an in order traversal. So what you have to do is you have been given the in order traversal or the sorted array. You have to build this tree. That's what has to be done. No, let's just let's have this. This was the binary. This was a sorted array. Now that's the same thing which we did. Coming to the fact, what should be our root? The root was 5. The binary tree which we saw, the root was 5, right? It was something like this. Then we know in order the paths to the right of the root and the paths to the left of the root respectively belong to the right and left subtree. Now, talking about this, we had these two roots. Again the left and the right subtree. We took the array that we got that was in order traversal. What we did, we found out the roots that were given to us. But now if we see the order, like we took the roots because we knew there was a tree. But now if you see in a practical approach what we actually did, we had an array. We took the middle element first. The middle element was our root. Elements to the left belong to the left subtree, elements to the right belong to the right subtree. Again, take this as another small problem. That's a recursive thing that we are going to do. This is again a sorted array. The middle of this array is your root. Again, the left and right being the left and right subtree. The middle of this array is your root. And again, being the left and right subtree, so on. So if you look at this question, basically just a straight thing. What you need to do is, you need to call a function that's building the tree. Let's say build tree, where you need to pass the array, the starting index and the ending index, right? So initially the starting index was this, ending index was n minus 3. This will give us the root, okay? Or in this build tree, what we are going to do is, we are just going to extract 0 plus n minus 1 by 2 index. This is going to be our root. Root right and roots left. Now roots right is, let's take this value as mid. Okay. So the roots right will come from this function, but the beginning would be mid plus 1 and ending would be again the same. This is for right. But for left, if you talk about, the ending will be mid minus 1 and this will be 0. So this is somewhere the binary search thing you used to do to change the searching thing. So that's what you need to do is, you need to take the middle element, and for that you know the mid plus 1 high and mid minus 1 low. For the left subtree, all you need to do is extract the middle, make the root. Extract the middle, make the root. Do it recursively until all the elements are done. That's what your question was. Now let's see how the code goes up. It's like extremely easy question. Try it on your own. We have a tree. Okay, sorry, coming here. First we had the sorted array to BST. We created a head node. This head node will pass the array, starting index, ending index. Coming here. First check, is there any validation that start is greater than end? Obviously that means they have crossed each other. There's no such possibility. Return null, do nothing. Now find the middle. If middle is there, the root will be nums.middle. Left would be start to mid minus 1 and right would be mid plus 1 to end. So that's what we are doing. It's recursively calling and then return the. I hope this is quite easy and it's clear. If not, then do refer to the properties of BST, because that's the basic thing that's required to do this. And somewhere you're in order traversal. I hope this should be clear. Even if there are some doubts, do let me know soon in chat box or in the comment box. And if there are any queries regarding anything, do let me know. Thank you.